We'll look at two more examples of applying this rational zeros theorem to come up with our list of rational numbers, p over q. Again, we'll start with all of our values for p, which would be all factors of positive 8, which would include plus and minus 8, plus or minus 1, plus or minus 4, and plus or minus 2. And then for q, we'll be looking at all factors of positive 4, so plus or minus 4, plus or minus 1, and plus or minus 2. From there, we can generate our list of rational numbers, which are potential zeros for our function, by pairing each value for p over a value for q. We would start off with positive 8 over 4, which would reduce to positive 2. Then we can consider positive 8 plus or minus 8 over 1, so that would give us plus or minus 8. And then we can consider plus or minus 8 over 2, which would give us plus or minus 4. Then we'll move on to our next value for p, and again, pair it with each of those values for q in the denominator. So that would give us plus or minus 1/4, plus or minus 1, and plus or minus 1/2. We would then move on to plus or minus 4. 4 over 4 would give us 1, which we already have represented. 4 over 1 would give us 4, which we already have represented, and 4 over 2 would give us 2, which we already have represented. Similarly with plus or minus 2, every pairing that we could match it up with, over 4, over 1, or over 2, is already represented in our list. So this would be our complete list of rational numbers that we would want to test as potential zeros for our function. In example 10, again the same idea. In this case, our only value for p would be plus or minus 1. And our values for q would be plus and minus 1 and plus and minus 2. This means we have a much shorter list of potential rational numbers to consider. We would have plus or minus 1 and plus or minus 1/2. So these lists of rational numbers that we can generate will give us a starting point to identify a potential zero. And once we do, use that as sort of a jumping off point to continue to find additional zeros and get to a fully factored form of a polynomial function.